created by commercial entities, software companies, and they're not publicly available in terms of how they're constructed. So it's kind of anyone's guess about how the files are put together. And in order to try and access them, if you don't have access to that commercial software, and if the company that made the commercial software goes bust, well, you've got to try and kind of deconstruct the file format. You maybe need to get someone very smart with development experience to kind of try and deconstruct it in order to get it delivered somehow. File formats that are open and non-proprietary, so publicly documented. The more open and non-proprietary a file format is, the better. So again, if it's a file format that is related to open source software that is not tied into any particular commercial interests, that there's a wide variety of different software that can be used to open this type of file format, it's not tied to one particular product, then that means that it's going to be a lot more sustainable. There's going to be different types of software that can read this data in the future, whereas it's not tied to a particular product or company. If there is a particular piece of software that is required to view data, then you're basically telling other researchers that they have to purchase that software in order to read that data, which makes it less important. File formats that are self-documenting are also a really good choice. So there are certain types of file formats where the file itself can include useful metadata. So yesterday we talked about metadata, so information about your data that to record. Some of that metadata can actually be embedded within the file. It means that instead of having to do documentation alongside your data, the documentation and data to kind of keep all of the useful information in one place. We'd also recommend that you choose wherever possible unencrypted file formats. So formats that encrypt themselves. Obviously, that doesn't lend itself to open data. If a file is that's not very open, and formats that are uncompressed or use a form of block, and file formats that are lossy compression. So when I talk about compression, I'm meaning there are certain types of image formats or audio or video formats that in order to make them more portable, in order to make them smaller and for storage purposes, so that they don't take up as much space, sometimes images and audio and video files can be compressed using certain types of algorithms. This reduces the quality of these media files. Ideally, when we're saving research data, we want the data to be of the highest possible quality. So sometimes you might need to save lower quality files. You might need to have more portable versions. You might be going to a conference and you need to have lower quality image files that you can put in a USB to take with you while you're traveling. that's fine, but it's always better to be able to have some master files that are of the highest possible quality for archiving purposes. So wherever possible, choose formats that are uncompressed or that use lossless compression. When you're using compression algorithms that are lossy, then you're losing data and you won't be able to get back that data if you're using those kinds of compressed formats. So with those kinds of criteria in mind, how does NetCDF stack up? So it's a very widely used format in a number of different disciplines. So it's used a lot in climatology, meteorology, oceanography, and in GIS, so Geographic Information Systems in particular, but it's widely used across a number of different science disciplines. It is a publicly documented file format, so these slides are hyperlinked so that where I say yes, it is publicly documented, that provides a link to the public documentation of the NetCDF file formats. It is open and proprietary, so again, that provides a link to the license where it tells you what you're licensed to do with the file format, telling you that it's open. It is a self-documenting file format, so this is something that Willem will also talk about. It's one of the reasons that he's chosen it, and it's included in the public documentation of the format that actually when you're constructing a NetCDF file, it includes metadata about the data as part of the construction of the file. So that's a very valuable thing in NetCDF files, that you include metadata as part of the file. By default, NetCDF files are not encrypted. I mean, all files can be encrypted, but it's not a fundamental part of the file format itself to be encrypted. And there's no compression included in an NetCDF file. So as a file format, it makes an excellent choice, a very sustainable, good preservation choice. And that's one of the reasons why Willem's chosen it for his own data. So yeah, does anyone have any questions about file formats? Or does anyone have any examples of file formats that you're using in your own data, or questions about what would be appropriate to use, whether the file formats you're using are appropriate as archival formats? Yeah, go on.
Can you make maybe a comment on database parameters, SQL, MySQL, and data that can maybe those kind of databases? Because many people are probably used for research these database formats. And what's the actually long-term sustainability, those kind of formats, with those kind of outputs that are being, because they're widely used?
Yeah, that's a really good question, because it depends on the size of the database.
I hadn't thought about that.
Yeah.
Really not.
Yeah. So in terms of sustainability, SQL databases, they are very widely used. They can be quite difficult to maintain in the long run, because in order to the actual environment to create and sustain and maintain an SQL database can be quite complex. You often need a server and clients, and so the overall environment for an SQL database to exist can be quite a complex one. So depending on the size and nature of database, what I've often ended up advising is to record the actual source code. So in some instances, I've worked with developers who developed databases, and what we've ended up recommending is to export all of the data in basically in CSV form. So CSV files are an excellent presentation format for tabular data sets. They meet all of the criteria for being very, very sustainable. And in terms of capturing the construction of the database, capturing the SQL source code, as opposed to the actual implementation of the database, that's also very sustainable. So if you needed to recreate the database in a new environment, you'd be able to do that. So that's how we've previously done it. It's not the same as having a working database, but you capture all of the information that you would need to recreate it. So you don't necessarily have. There's also like I said, it depends what you're needing. There's also emulation environments that you can create. So there's systems like Docker, which is an emulation environment that allows you to create a little virtual server. So you could set up a little virtual database server where you can install the database, and that would be one option as well. Smaller databases, I know some people use like Microsoft Access. So if you're not using SQL, but you're using kind of smaller databases on things like Microsoft Access, I would be suggesting using the LibreOffice. There's LibreOffice Base, which is an open source version, which can open Microsoft Access files. So Microsoft Access is proprietary, whereas LibreOffice Base is open source, so it needs more of it's non-proprietary, whereas Microsoft Access is proprietary. So yeah, databases can be tricky. Sometimes just exporting the data that you need in a CSV file can be the simplest. So,
but yeah, I think probably what I was thinking myself as well. But I think the other key thing with that is that with it is you have to have again a good editor file, a good description file, like the SQL code or some database or some way so people can interpret different CSV tables, export, and have a folder structure that clarifies exactly where each of the so it's something like that I struggle with myself. I have this database system and I export it to text file because it is easy to manage. So it's just, yeah, I don't know, maybe some of you do use SQL. This is quite widely used, it's quite very widely used. And maybe listening to this.
Ya, siap pertanyaan. Ini masalah file format. Jadi file format itu sebenarnya sudah pernah disampaikan pada sesi yang sebelumnya dan kemarin. Jadi file format itu harus yang paling portable, yang bisa dibuka oleh semua orang dengan spesifikasi kalau bisa yang minimum. Jadi men-save file itu masalah software, masalah hardware, dan jadi you need to define specific formats that most of the computers can open. Yeah. Most software can open it. Most computer with general specification can open it. And
Yeah, so if you're making your data open, you really want to be thinking about if someone else is going to be opening your data on, they might be on a, Owen's using Mac, Willem's using Windows, I'm using Linux, so we're all on different platforms, but we're all sharing a repository. We're all working on the same files. We all want to be making sure that we can open those files and work with them across different computing platforms. We're using different software, so you want to make sure that the formats that you're using can be used by different people. Systems.
CDF to binary, right? The binary format of asking. You need the software also to open.
Yes, the software is open source.
But it's open.
So the XDF software, the underlying software is open source. Run by
Yeah, so the file format is open, and the software that you need is also open, free. Yeah.
I think the binary is small, so that's the reason why they use it. The binary is actually a small file format.
So it's compressed.
Yes, but it's without loss of information. So it's compressed without loss of information. So, and the main thing with NetCDF is that it's specifically good for spatial and temporal data because it's a data cube. So it allows you to actually slice that way, so you can go spatial or temporal, and so that makes you can extract a point. So that makes, and that's the reason why the methodology actually people use a lot, because you actually you have a global data set and you can just extract one point out of it. That makes it really useful. So it's easy to do that once you have it in that format.
Use also in other fields,
I know I haven't seen it much because it's not when it's non-spatial or non-temporal, then it becomes trickier.
Primarily earth sciences.
Yeah. It's mainly people working with spatial temporal data.
But it is used very widely in the earth sciences. So
Yeah.
so if it sounds like in the email,
Yeah.
like format.
So which one?
Apa pertanyaannya? Yeah. Yeah, he was asking about what if we submit various kinds of data, video, barcode, yeah, and can we use the net CDF?
No, and NetCDF specifically for spatial temporal data, so things that come out of QGIS or things that come out of like paleo or something like that, which is spatial and depth. You can use it for that. So anything that has multiple dimensions. The video data, no, quite different. So yeah, you need to think of different formats. I mean, NetCDF is one format you use for spatial temporal data, that might be video data, that might be different other format that you use.
So it's one one.
So yeah, so NetCDF would be an appropriate file format for specific types of data, so GIS style data, but there's certainly other types of data that it wouldn't be appropriate for.
Papers.
Yeah, it's one file.
Yeah.
I can basically put the whole world in one file. One NetCDF file. Yeah, it's basically, and so that's what I'll show tomorrow in the demo. I'll create one of those CSV files and create a NetCDF file. Layers of NetCDF files as well.
One file.
If you want to get
but there's certainly an awful lot of data that NetCDF wouldn't be appropriate for. So, and there's lots of disciplines that don't use CDF because NetCDF because it wouldn't suit the type of data that they work with. Music doesn't use NetCDF because it doesn't fit their data. Yeah, there's all kinds of disciplines that it's not appropriate.
This is really for the earth science. So we thought, for this group, which is mostly earth scientists, this is an interesting file for them. But for people who, from the population, you could actually put it in But I mean, text data, that's why I asked the question about database about SQL, because I mean, lots of people use SQL to store a lot of, interview data or things like that, in databases. And so it's quite different. The video formats and JPEGs and images, I think there is not yet. I don't think there is a format at all. Again, there's a range of different image formats, and I think one of those.
There are a range of image formats. So JPEGs are actually they are one of the types of images that use lossy compression. So they're not ideal as a type of master image. TIFF and PNG, portable network graphics, are the preferred type of images as master image files. But that's not to say that you can't use JPEGs in some instances. So if you're doing research that involves, sending images forward and back to collaborators over email a lot, sharing, then you might have your master files that you keep in an archive, but then your working files might be JPEGs. And there are some preferred video formats, but there's less standardization on that as well.
And the other question about code files. Code files tend to be very, very small. No matter what code you write in, the actual file is tiny compared to a lot of the data files.
It's just plain text.
So code is just plain text. Yeah. Essentially, code is just plain text files. So they're very easily stored because they take a minimum of the total storage on that they're actually dealing with. And that's the reason why GitHub needs all kinds of space, because you don't actually use that much space. Right? They won't allow very big files because you have to do something else. But that's because they're just, code are just very small files and they don't really worry about that. The data can be converged, and this is for the actual data that this is specifically for geospatial temporal data. So I was saying the RPCC, the International Climate Change, they all their data from all their output from the models is all NetCDF because it's geospatial, it's temporal, it's that kind of data. You can think of warlocks that can go, you can never be able to go in NetCDF. Geophysical data, they work really well, the actual raw data, the actual things that come out of the chip, they work really well, because it's got location, it's got trace, temporal or spatial trace which you can use. All that can go into the file.
But basically, it's tabular data.
It tends to be numerical, it tends to be tabular or matrices, or multi-dimensional matrices. So it can be four-dimensional, or even multi.
Itu Mas Andro. Jadi NetCDF itu tabel, intinya tabel.
Well, the most I've tried was 4 dimensions, which was 2 spaces. That's fine. Those are different variables. You can have those, but it's more space, depth, and time. I think yeah, possibly. So if you can think of another, actually, I don't actually know another dimension than time and space and depth. If you can think of another dimension, some computing space.
Salinity.
Well, that's not a problem. That's a different variable. So each of these variables will have point data in space. They will have time data, or they might have depth data. But each of those, but they're different variables. So you can store all the different variables within those 4 dimensions. I don't think they're agreeing on dimensions at the moment. So really, in terms of dimensions, I can only think of 4. But you can store all 4 dimensions within an NCBF file. You can understand that it has space and depth and time. You add all those together. And then you can extract basically, you can tell it, I want only this time, that space, and these depths. And then we'll extract that for you. So that's the reason why for geospatial data, it's a perfect form. For science data, it's a perfect form. A lot of information today, sorry about that.
Baik, saya sedikit menambahkan, ini bisa juga kita mengkompres data. Jadi misalnya ada video, rekaman, interview misalnya, itu kan mungkin beratusan mega, itu bisa dikompres. Cuman cara mengkompresnya harus juga mempertimbangkan software kompres yang berlaku umum. Zip, tab, dan yang lain. Jadi para pengguna harus bisa mendekompres file dengan mudah. Itu saja. Jadi pada saat dan Bapak men-save file, maka pikirkan apakah Bapak Ibu bisa membuka lagi itu dengan cara yang paling minimum. Itu yang paling penting. Jadi ya, maka kalau kita lihat acara Tuesday, kita sudah
So what I'm doing is I'm shifting this last activity, or the rest of this last activity. We're shifting that to here, and I'll try and combine this. So that I can show you there is an exercise on the internet. Again, I'm feeling that maybe R is not as fluent, so maybe I'll just leave it as a demo showing you how it works. And then you can look at it rather than doing the activity that everybody. Although if you want, we can do the activity, but we'll try it. Depends a bit on how well you're going with your R. That's really what I'm. Otherwise, if I go and sit here and do a lot of R, then maybe you'll really struggle to do that. So I prefer to make sure that you're getting the information rather than having to do too many things that are really, really hard. If they're or people think they're really, really hard.
Yeah. Jadi kita sudah mengenal RDM tadi dengan UMP tools, ya kita bisa membuat rencana pengelolaan desa. Ya, kemudian sedikit R, kemudian kita akan kita ulang satu saat. Kita dari urutan jadwal agak kacau jadi masalah. Dan CDF. Nah, ini akan dilakukan oleh masalah CDF, right?
Yeah, so Jean gave the introduction into file formats. The idea of file formats, that all file formats can be important. Tomorrow I'll just combine and show a little bit more about how the CDF works and how we make an SPF file.
Then
so that will be combined with that. Then we'll go into the rest.
Ya, jadi kemudian besok kita juga akan belajar tentang repository dan dengan beberapa kegiatan bisa dimanfaatkan nanti ketik R lagi untuk GitHub. Oke, mudah-mudahan orang yang sama mungkin bertambah besok diganti. Terima kasih. Selamat sore. See you tomorrow. Assalamualaikum warahmatullahi wabarakatuh.
Bisa nggak ada materinya? Yang betul.